Hi students, it's me, Dr. Loh here. Today I will discuss Chapter 10, Vector Integration. This chapter covers three topics: line integral, surface integral, and multiple integral. This chapter is a little bit lengthy, so I will break down into two section videos. Now we will begin with part 1, question 1. In the first question, you are asked to evaluate line integral x minus y ds along C of parametric equations given x in terms of t, y in terms of t, and the t values are bounded from 0 to 1. We will make use of the line integral formula. There are only two variables involved. Okay, so fxy ds, when x written in terms of t and y written in terms of t, we substitute the x and y values by terms of t. To convert ds to dt, we multiply by square root of x prime square plus y prime square dt. Substitution of x value. Substitution of y in terms of t. To convert ds to dt, according to the formula, differentiate the x, differentiate the y, so ds convert to dt. T is given from 0 to 1. So it's a direct computation of integration. Move on to question 2. Evaluate line integral along C whose parametric equations given by x, y, z. Now we have three parameters or three variables. T bounded from 0 to 1. Similar to question number 1, we make use of the line integral formula. Now the difference is we have 3 variables or 3 parameters, x, y, and z ds. So substitution of x, y, z in terms of t, and to convert ds to dt, we need to multiply by the square root of x prime square, y prime square, and z prime square. Z in terms of t, y in terms of t, there is no t involved for the y parameter, meaning that it is actually equals to 4t to the power of 0. To convert ds to dt, is the square root of differentiate x in terms of t. Differentiate the y. Differentiate the z. And ds change to dt. T boundary values are given 0 to 1. Simple computation of the integration. Next, question number 3. Find again the line integral 3x ds along curve C of parametric equations x equal t, y equal t square, t from 0 to 3. These are all simple direct calculations of line integrals. Substitution. To convert ds to dt, by formula square root of differentiate the x, differentiate the y. dt. T bounded from 0 to 3.
Tonight, my heart's beating just for you. I'm dancing right here just for you. Make me feel, you make me feel.
So how do you differentiate 3t square root of 1 plus 4t squared dt? So we need to substitute to simplify the integration.
We stand together, we'll make it through the night. The world is ours for the taking, if only for tonight. My heart's beating just for you. I'm dancing right here just for you. Make me feel you.
So substitution into the integration. dt convert to du. So now we can cancel out the t. We note that dt is from 0 to 3. T calculated from 0 to 3. Now if we convert to du, so it is no longer 0 to 3. What is the u? U equal to 1 plus 4t squared. So when t equals to 0, when t equals to 3. So to integrate in terms of du, it is no longer 0 to 3. We need to convert to du, u from 1 to 37 corresponding to the t values. So calculation from here should give you the last answer. Question 4 now. In this question, you are asked to evaluate line integral along C and upper half of a circle radius 2. Now the C is bounded by half of a circle with radius 2. Consider C parameterized as x equal to cos t, y equal to sin t. This is in terms of a polar parametric, and the t bounded from 0 to pi. Substitution of y in terms of t. So similar to previous questions 1 to 3. So it is still the same concept. Conversion of ds to dt. The square root of x prime square plus y prime square using the formula of line integral. So differentiating the x gives us differentiating the y t bounded from 0 to pi, so we can replace this. Calculation from here with the formula of sin square plus cos square equals to 1. Formula of trigonometry. So simplification from here. So simple integration. Move on to question number 5. This question is interesting. If a force F vector in terms of 2x squared yi plus 3xyj displaces a particle in the xy plane from 0, 0 to 1, 4 along a curve y equals to 4x squared, find the work done. You are given the force and the question is to find the work done. Remember what you have learned in physics? Work done is equivalent to force multiplied by the distance. In symbol, F times S. So in this case, we have the force. How about the distance? Distance is given implicitly from the question, from coordinate 0, 0 to 1, 4 along the curve. So what we do here is the line integral. So the work done is equivalent to the force multiplied by the distance in terms of vector and the integration from the coordinates given. Dot with the dr. R is a position vector as mentioned in the previous chapter. The position vector is in terms of two coordinates, x and y dimension. So by default, position vector is written as xi plus yj. But what we want here is the dr. So we differentiate the r . So these two vectors are in terms of dot product. So calculation by dot product. This is not done yet because it is bounded by along a curve. The curve given by the parametric equation y equal to 4x squared. So substitution into the function y equal to 4x squared. And dy in terms of dx. Notice that now all the terms are in x, in terms of x. So, following the coordinates, x coordinate is evaluated from 0 to 1. A simple integration calculation. So calculation from here gives the last answer. Question 6. You are given the force vector equals x negative y. Compute the line integral f.dr along C, the line segment from 23 to 03. With parametric equations, x equal to 2 minus 2t, y equal to 3, t from 0 to 1. This is more or less similar to the previous question 5. Computing integration of f.dr meaning that we are computing the work done. In the previous question, we write R position vector in terms of x and y. So dr meaning differentiate the x, differentiate the y. In this question, the f vector is given in terms of, okay, again, x and y. X, negative y. dr. This question is a little bit tricky because it is given in terms of parametric equation. X is given in terms of t, y in terms of a number. So we can substitute this. dx. So we differentiate this. dy. So we convert x and y in terms of t. So this will be in terms of dt. We are given t from 0 to 1. So this is just a simple integral calculation. That gives you the last answer, negative 2. Now we look at question 7. We are given the force vector z negative y x. Compute the line integral along C line segment from the given coordinates of parametric equations. We have seen many of the similar type questions, so they are just a repetition of the same concept. Substituting the parametric equations, so derivative, differentiating the x, y, and differentiate the z. These are all in terms of t, so dt. T given from 0 to 1. So once you have come to this step, the remaining are just simple integral calculations. Thanks for watching. Drop a like, leave a comment, and don't forget to subscribe.